Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. And please, as you watch this video, endeavor to subscribe, like, share, and comment. And please, as you watch this video, I will advise you pay proper attention and do not allow anything to distract you, because what we're about to do right now will be a bit confusing, but it is going to be very easy so long you give it your full attention. And we have on the board dimension of van der Waal equation. Dimension of van der Waal equation. You know, the van der Waal force is a weak force of attraction that bind molecules of gases together. Take for example the noble gases. The noble gases have negligible force called what? The van der Waal force of attraction. And that is why gases are able to move randomly or zigzagly or haphazardly in the container in which they are found, because the force that binds their molecules together is negligible. And secondly, you should also note that when we talk of carbon, the crystalline form and the non-crystalline form. The crystalline form we have graphite and diamond. The non-crystalline you have the soot, or the lamp-black, the coal and the coal. But the coke and coal, alright? My emphasis is on graphite and diamond. Diamond is not able to conduct electricity because the crystals are strongly joined together by a strong covalent bond, and that is why the electrons found in diamond are not able to move freely. Hence we call them immobile electrons, because the crystals of diamond, or the electrons, have been joined together by a strong covalent bond. What about graphite? Graphite, which is a major constituent of lead pencil, is a good conductor of electricity because it has a free mobile electron. If it has free mobile electron, it means that the electrons found in graphite are weakly joined together by van der Waal force. Okay, so van der Waal force is found in graphite, but covalent bond is found in diamond, and that is why it is not able to conduct electricity. But diamond can conduct heat. Take note of that. Now let's jump into what we have on the board. Dimension of van der Waal equation. Dimension of van der Waals equation. Now this is what we are going to do. That is what we are going to do. First and first, I shall write out the equation, and I will take my time to explain each parameter. And the equation is written as P plus A open bracket N over VR squared, then times open bracket of V minus N minus, that is V over N minus B, all equal to RT. Now the P here stands for pressure and is measured in millimeter mercury, or atmosphere, or torr, that is TORR. The P here stands for pressure, and of course know that pressure is force over area. Okay, now the A which we are trying to deduce represents the intermolecular forces that bind, or that is the intermolecular forces between the gaseous molecules. A stands for the intermolecular forces between the gas molecules. Okay, now then N stands for number of moles, and V stands for volume, which is L cube. V volume, B N number of moles. Then V stands for finite volume. The B stands for the finite volume, or excluded volume, or co-volume. Alright, or it represents the volume in which the gas molecules occupies. Okay, it therefore means that B is responsible for the molecular size. I take it again. B stands for finite volume, or co-volume, or excluded volume. It expresses the volume that the gas molecules themselves occupied, and is responsible for the molecular size. And A stands for the intermolecular forces between the gas molecules. And R here stands for the gas constant. R is the gas constant, and the unit is joule per mole per Kelvin. If I don't express like this, I can say joule per mole per Kelvin. That is, this minus 1 as a power is pronounced as par. So joule per mole per Kelvin, okay? Or joule per mole per Kelvin, okay? So that is how it is. And of course, T here does not represent time. It stands for what? Temperature. And temperature is best measured in Kelvin, okay? I know we have the Fahrenheit scale and we have the Celsius scale. But in this case, we are using Kelvin scale. That's Kelvin, okay? Now, what am I going to do? First and first, I have to deduce for rate. Normally, if just as we jump into deducing dimension of A and B, we are not going to be making use of R and C, but for a better understanding, I would love to include it, okay? Now, the gas constant, okay, before we do that, let's introduce the ideal gas equation. Ideal gas equation. And of course, the ideal gas equation is given as PV equals nRT. Alright, that is the ideal gas equation. It is an equation that combines Charles, Boyce, and Avogadro's law together. So, general gas equation it is made up of Boyce and Charles law. Alright, but the ideal gas equation is made up of Boyce law, the Charles law, and Avogadro's law. Take note of that. We are making R the subject formula as the divide both sides by RT, that is by NT, N going to N and T going to T. I have what? I don't have R. And R is PV over T. Please, the N is to be neglected, okay? The N in this case is not going to be used. Please take note of that. And please don't forget that this T here, C or K, let me introduce K so you don't feel it's time. Now, pressure is force over area. The dimension of pressure is M L minus 1 T minus 2, then times volume, which is L cubed. I think I will bring it down. Let me bring it down, please. Let me bring it down. I'll bring it down, okay? So R is equal to M L minus 1 T minus 2, then times L cubed over K. Alright, don't forget that pressure is force over area. Force over area. Force is MLT minus 2 over L squared. So if one L cancels out one L here, I'm left with what? One L. So if this L goes, so it becomes L minus 1 T minus 2. Alright, so that's how I got this. Very easy. Now from what I have now, it becomes R equal to M L minus 1, right? M, that's L minus 1, okay? Then not yet. So minus 1 plus 3, I have 2. Then if this K goes, it becomes what? K minus 1, alright? Alright, so therefore, R is equal to ML2 T minus 2, then K minus 1. I didn't include the T here, please. C minus 2, then K minus what? 1. So this is the dimension of the gas constant. ML squared T minus 2 and K minus 2. That is how it is. Very, very important. Very, very important, okay? So I'll say mass L cube per time, then per Kelvin, okay? So this is the dimension of the gas constant. So that is for that. Now let's jump into Avogadro's law properly. And please, in deducing dimension for certain quantities, there are rules and regulations that must be obeyed. For example, if I'm having A plus B, this means A equal to B and B equal to what? A. That is what it means. Alright, if I'm having V minus C, it therefore means that V is equals C and C is equals what? V. That is how it is, okay? Okay, if that has been assimilated, let's go into this properly. So if I should open up this expression, I'll be having P plus AN squared over what? V squared. True or false? True. These two outside as a power affect everything inside the brackets. And of course, I told you guys before that this n squared is not to be considered, so it is cancelled out. So I will now be having P plus A over what? V squared. I initially mentioned that if we are having this, therefore it means that P is equal to what? A over what? V squared. True or false? True. Then, if I should cross multiply, I'll be having A equals what? P times what? V squared. Is that what it means? Yes. A equal to P is what? Pressure. Pressure, which is ml minus 2. That's minus 1. C minus 2 times L cube. L cube, right? But it's raised to the power of 2 times 2. I'll now be having what? 6. 6. Alright? So if that is the case, it therefore means that the therefore A becomes M minus 1 plus 6. I have L5, right? Then I have what? T minus 2. Alright? So this is the dimension of A from the van der Waals equation. Now we have compared, we have exhausted everything here, so we are left with this. If that is the case, I told that V over N minus B, alright, it therefore means that V is equal to what? B. I told you that N is to be neglected. Therefore, B is simply L cube. It shock you a bit. It just shock you like this. I know say it shock you, but that is how it is. Very, very easy. If you don't know, you don't know. If you know, you know. Okay? If you are willing to know, you will know. But some persons, they know that they don't know, and they are not willing to know, and they will never know. That is how it is. So we say learning never ends. Okay, learning never ends. So that is how, very simple. Just follow it step by step. Okay, but let me bring in another equation that I would love to explain it, but I've explained it on my WhatsApp group, that is the platform, but I would love to also bring it here, that V is equal to the square root of 8t plus bt plus c over d plus t. Alright, so we are going to look for the dimension of A, B, C, and D. A, B, C, and D. This is how you are going to go about it. It is very, very easy. This is how you are going to go about it. Very, very easy. Now, having this expression, I'm going to compare this to this, this to this, this to what? This. Good to go. Now, this is what we are going to do. So it becomes V equal to the square root of 8c. Alright, this square root is an obstacle. In order for me to kill it out, I'll say square both sides. So these two cancels out these two, and I'll be having V squared equals to what? 8c. Right? That has been settled. Now this V present velocity and not volume. No, velocity is L over T, all raised to power 2 equal to A times big letter T, because we are talking of dimension. Okay, so over 1. So this expression becomes L squared T squared equal to what? A times T. True or false? True. Now if this T goes up, it becomes L squared. Let me reduce the size of the alphabet. L squared T minus 2 equal to what? A T. Divide both sides by T. This will go into this. Therefore, my A becomes, if this T goes up, it becomes LT, that is L squared T minus what? 3. That is T minus what? 3. So this is the dimension of what? A. Very easy. Now the next thing to do is to compare this with this. That is V equal to what? BT. LT minus 1, which is velocity, right? Then B times what? T. Divide both sides by T because we are looking for what? B. This will go into B. That is T will go into T, and now that B is equal to, if this T goes up, becomes what? Minus 1. So I'll be having T, that is, I'll be having L equal to minus what? 1. So that is how it is. Very, very easy. That is how it is. Extremely easy. Okay, now if that has been established, we'll go into deducing for what? C. Deducing for C. That is, we are going to be comparing this with the whole of this equation. That is V is equal to C over D plus what? C. And I told you if we are having something like this, it means that D is equal to what? C. Therefore, V is equal to C over T. Everything here becomes what? C. What do I do next? This times this is this equal to V times what? C. So C is equal to, V is LT minus 1 times what? T. Right? Times T. This guy, there's an invisible plus 1 here. So minus 1 plus 1 is nothing. I have T0. And 3 raised by 0 is 1, according to the law of what? Indices. So C becomes L. So the dimension of C is simply L. Just L. Alright? To proceed further, if I'm having D is D plus T, and I told you also that D is equal to T or T is equal to D. Therefore, the dimension of D is just equal to T. You shock you, Abby? That is how it is. Very, very easy. Very, very easy. Okay. And currently, I'm doing online classes. All right. You are going to be paying a token. If you are interested in the online classes, just chat me up on 091 All right. The monthly fee is just 3,000. All right. Monthly fee. The whole month you are paying just 3,000 naira, which is quite cheap compared to what you are going to be gaining. But we know that everything boils down to God's grace. So if you know you learned something, if you learned a new thing in this video, please do not be reluctant to subscribe. Please subscribe and help my channel to grow. Do have a wonderful day.